If you think single-engine turboprops are slow, this list is about to change your mind. Modern turboprops have evolved far beyond the traditional image of a small propeller plane, combining powerful turbine engines, advanced avionics, pressurized cabins, impressive range, and speeds that can approach or even exceed 300 knots. In this video, we're looking at 15 single-engine turboprops, from rugged utility aircraft built to reach remote airstrips, to sophisticated personal and business aircraft designed for high-speed travel. Some are affordable compared with light jets, some deliver incredible value through efficiency and versatility, and others push performance to a level that seems almost impossible for a propeller-driven airplane. We'll work our way from number 15 all the way to number 1, where one aircraft reaches a published cruise speed of 330 knots. So, which turboprop offers the best combination of speed, technology, comfort, and real-world capability? Let's find out. Number 15. Cessna Grand Caravan EX. Starting off with number 15 is the Cessna Grand Caravan EX, and this is the kind of aircraft that makes you realize why speed is not always the most important thing in aviation. While it cannot compete with the high-speed turboprops later on this list, the Grand Caravan EX has built its reputation around something arguably more valuable: getting people and cargo where they need to go, with minimal fuss, and from airports that many faster aircraft simply cannot use. Powered by the proven Pratt & Whitney Canada PT6A-14D, the Grand Caravan EX delivers 867 shaft horsepower, and its design is centered around durability, simplicity, and versatility rather than luxury. The high-wing configuration gives passengers and crew excellent visibility while keeping the propeller and engine away from much of the debris found around rougher airstrips, and the rugged landing gear is designed to handle the kind of operations where a conventional business aircraft would be completely out of its element. Inside, the cabin can be configured for passengers, cargo, or a combination of both, and that flexibility is one of the biggest reasons operators continue to choose the Caravan. You can use it for regional passenger service in the morning, carry freight in the afternoon, and support remote operations where paved runways are not guaranteed. That is where the Grand Caravan EX delivers its real value. It is not trying to be a cheap jet, and it does not need to be. The aircraft's operating concept is built around a relatively simple single-engine layout, a highly proven PT6 power plant, excellent low-speed handling, and short-field capability. Cessna lists a maximum cruise speed of around 185 knots and a maximum range of approximately 912 nautical miles. But in everyday operation, the ability to carry a substantial payload into smaller airports can be more important than another 50 or 100 miles per hour of cruise speed. The aircraft is also widely supported, which matters enormously for commercial operators because parts, maintenance knowledge, and experienced technicians are easier to find than they are for many specialized turboprops. The downside is obvious. Compared with pressurized aircraft such as the PC-12 or TBM family, the Caravan is slower, less luxurious, and not designed for high-altitude business travel. But that is exactly why its price and operating economics can make sense for the right mission. New Grand Caravan EX aircraft are typically sold through Textron Aviation rather than at a simple published retail price, so buyers generally work with the manufacturer or dealer for an equipment-specific quotation, while used aircraft prices can vary substantially with age, engine time, avionics, and configuration. What you are really paying for is not raw speed, but an extremely flexible aviation platform that has proven itself in passenger transport, cargo, charter, humanitarian work, and remote area operations. And that is why the Grand Caravan EX earns its place on this list. It may be one of the slowest aircraft here, but when the runway gets shorter, the mission gets tougher, and the cargo becomes more important than luxury, this rugged turboprop can suddenly look like one of the smartest choices in the entire category. Number 14. Daher Kodiak 900. Moving into number 14, we have the Daher Kodiak 900, and this is one of those aircraft that proves a turboprop does not have to chase jet-like speed to be seriously impressive. The Kodiak 900 is essentially a larger, faster evolution of the Kodiak family, designed around a very different philosophy from aircraft such as the TBM 960 or Epic E1000. Instead of focusing primarily on high-altitude business travel, Daher built the Kodiak 900 to carry people, equipment, and cargo into places where conventional aircraft may have very few options. Its Pratt & Whitney Canada PT6A144A engine produces 900 shaft horsepower, giving the aircraft a maximum cruise speed of around 210 knots, or roughly 242 miles per hour, while the published maximum range is approximately 1,129 nautical miles. Those numbers may not sound spectacular compared with the faster aircraft later on this list, but they become much more impressive when you consider what the Kodiak 900 is actually designed to do. The aircraft has a rugged, high-wing configuration, fixed landing gear, and strong STOL capability, allowing it to operate from short and unimproved runways, where a sleek business turboprop or light jet would simply be a poor choice. The large cabin can be configured for passengers, cargo, or specialized missions, and the aircraft can quickly transition between different roles without requiring a completely different airframe. That versatility is one of its biggest strengths. A Kodiak 900 can be used for remote transportation, charter operations, cargo delivery, humanitarian missions, aerial surveying, medical evacuation, or simply taking a group of passengers somewhere far away from conventional airports. Daher also made aerodynamic improvements to the 900, including a redesigned wing and longer fuselage, helping increase speed and efficiency while giving operators more useful cabin space. The aircraft remains unpressurized, which is an important disadvantage if your mission involves frequent high-altitude travel, and its relatively modest cruise speed means it cannot compete with the pressurized TBM or PC-12 family when the priority is covering long distances quickly. But that limitation is also part of the reason the Kodiak 900 can be so effective. Its design avoids unnecessary complexity and focuses on durability, accessibility, payload, and low-speed control. Pricing depends heavily on configuration and equipment, but the Kodiak 900 sits firmly in the modern premium utility aircraft market rather than being a budget turboprop, with new aircraft generally requiring a direct quotation from Daher. Used Kodiak aircraft can also command strong prices because of their reputation and specialized capability. Ultimately, the Kodiak 900 stands out because it does something that many faster aircraft cannot. It gives you serious turbine performance without sacrificing the freedom to operate far away from major airports. If your definition of an effective aircraft is not simply how fast it can fly, but how many different missions it can handle, the Kodiak 900 becomes one of the most convincing aircraft on this entire list. Number 13. Piper M500. At number 13, we have the Piper M500, and this aircraft takes a very different approach from the rugged utility machines we just looked at. The M500 is a pressurized, 6-seat single-engine turboprop, built primarily for owners who want to travel farther and faster without moving into the complexity and operating costs of a light jet. Under the cowling is the proven Pratt & Whitney Canada PT6A42A, producing 500 shaft horsepower, and that gives the M500 a maximum cruise speed of around 260 knots, or roughly 299 miles per hour. That is not enough to challenge the fastest aircraft on this list, but for a relatively compact turboprop, it is still serious cross-country performance. The M500 can also operate at altitudes up to 30,000 feet, giving pilots the ability to climb above much of the weather and make better use of favorable winds, while the pressurized cabin creates a much more comfortable environment for passengers on longer flights. Inside, the 6-seat club arrangement gives the aircraft a practical executive layout, with enough space for business travel without turning the airplane into an oversized luxury cabin. The real attraction, however, is the balance between performance, technology, and operating simplicity. Piper paired the M500 with Garmin G1000 avionics and the GFC 700 autopilot, giving the pilot a modern glass cockpit with features designed to reduce workload. Electronic stability protection helps prevent the aircraft from entering certain dangerous flight conditions, while underspeed protection, automatic level mode, and coupled go-around capability add additional layers of assistance when workload becomes high. This technology is especially valuable because one of the biggest advantages of a single-engine turboprop is that it can give an owner impressive transportation capability without requiring a professional flight department. The M500 can be flown by an appropriately qualified owner-pilot, making it an attractive alternative to stepping up to a more expensive jet operation. Of course, there are compromises. The cabin is smaller than what you get in aircraft such as the PC-12. The range is not designed for extremely long non-stop missions, and 260 knots is noticeably slower than the TBM family. It is also no longer Piper's newest M-class aircraft, so buyers in today's market need to consider whether a used M500 makes more sense than moving into a newer M600 SLS or M700 FURY. New M500 pricing is no longer the main focus of Piper's current lineup, so the actual purchase cost depends heavily on the used aircraft's year, engine hours, avionics, maintenance history, and overall condition. And that is exactly where the M500 can become interesting from a value perspective. You are getting a pressurized cabin, a reliable PT6 engine, modern avionics, and nearly 300 miles per hour of cruise performance in an aircraft that is far more compact than a typical light jet. It may not be the flashiest turboprop here, but the M500 succeeds because it delivers a very sensible combination of speed, comfort, efficiency, and practicality, making it one of those aircraft that makes a lot of sense once you look beyond the headline numbers. Number 12. Piper M600 SLS. Moving up to number 12, we have the Piper M600 SLS, and this is where the M-class philosophy starts to feel much more like a modern executive aircraft than a traditional turboprop. The M600 SLS was developed for pilots who wanted serious cross-country performance, a comfortable pressurized cabin, and a level of cockpit automation that could make single-pilot operation more manageable. Power comes from the proven Pratt & Whitney Canada PT6A-42A, producing 600 shaft horsepower, and Piper lists a maximum cruise speed of around 274 knots, or approximately 315 miles per hour. The aircraft can reach a maximum operating altitude of 30,000 feet, while its published maximum range is approximately 1,658 nautical miles, giving it enough endurance for substantial regional and cross-country missions. But the M600 SLS becomes truly interesting when you look inside the cockpit. Piper equipped it with the Garmin G3000 avionics suite and its Halo safety system, bringing together technologies such as auto-throttle, electronic stability protection, emergency descent mode, surface watch, safe taxi, and Garmin emergency autoland. The autoland system is arguably the feature that gets the most attention, because if the pilot becomes incapacitated, the system can take control of the aircraft, select a suitable airport, navigate there, and perform an automated landing. That does not make the airplane pilot-proof, but it adds a remarkable layer of protection to a class of aircraft often flown by a single pilot. The M600 SLS also benefits from a pressurized cabin, allowing passengers to travel comfortably at higher altitudes, while the aircraft takes advantage of smoother air and more favorable winds. From a design standpoint, Piper kept the aircraft relatively compact, which is actually one of its advantages. It does not require the huge infrastructure associated with larger business aircraft, and its single-engine configuration keeps the overall mechanical layout simpler than a twin-engine turboprop or jet. The trade-offs are equally important. The cabin is considerably smaller than a PC-12. The aircraft cannot match the 330-knot cruise speeds of the fastest TBM models, and the useful load requires careful planning when the aircraft is fully fueled with several passengers and baggage. The M600 SLS is also no longer the newest aircraft in Piper's M-class lineup, with the M700 FURY now occupying the top position, so buyers considering one today will largely be looking at the used market. Pricing can vary significantly depending on year, total airframe time, engine hours, avionics condition, maintenance history, and optional equipment. But that can also create an opportunity for buyers who want modern Garmin automation and autoland capability without paying for the newest possible airframe. What makes the M600 SLS stand out is the way it combines these technologies with real-world performance. It is not simply a fast propeller airplane, it is a highly automated, pressurized personal aircraft designed to make long-distance flying faster, more comfortable, and potentially more manageable for a single pilot. Number 11. Daher TBM-700. At number 11, we reach one of the aircraft that helped create the modern high-performance single-engine turboprop category, the Daher TBM-700. When the TBM-700 entered service in 1990, it was a radical idea for the time. Take a pressurized 6-seat airframe, install a powerful Pratt & Whitney Canada PT6 engine, and create a personal aircraft capable of speeds normally associated with much larger and more expensive machines. The TBM-700C2, one of the later and more capable variants, uses the PT6A64 engine, producing 700 shaft horsepower, and can reach around 300 knots in high-speed cruise, or roughly 345 miles per hour. That is still an impressive figure for an aircraft designed more than 3 decades ago. The real genius of the TBM-700, however, is not just its speed. Its relatively compact airframe, pressurized cabin, retractable landing gear, and efficient turbine engine created a combination that gave owners genuine business travel capability without the complexity of a twin-engine aircraft. It could climb above much of the weather, cover long distances quickly, and still use smaller airports that might not be practical for many light jets. The design was also developed with maintainability in mind, and Daher continues to support the TBM fleet with technical assistance, parts, maintenance programs, and avionics upgrade options, even though the TBM-700 itself is no longer in production. That long-term support is a major advantage when considering one today. The downside is that you are buying an aircraft that can be more than 30 years old, so condition matters enormously. Engine time, propeller history, corrosion, landing gear condition, pressurization systems, avionics, and maintenance records can make a huge difference between a great TBM-700 and an expensive project. The used market also shows why these aircraft can be interesting from a value perspective. Current listings in 2026 show TBM-700B and 700C2 aircraft offered around the $1.3 million to $1.7 million range, although exceptional examples can command more and actual transaction prices vary considerably. That is a fraction of the purchase price of a new TBM-960 or TBM-980, while the basic performance concept remains remarkably similar. Of course, the older cockpit, older systems, and age-related maintenance requirements mean you cannot compare an early TBM directly with a brand new aircraft. But that is also what makes the TBM-700 so compelling. You are getting a genuine pressurized turbine aircraft with near-jet speed, a proven PT6 power plant, 6-seat capability, and a design that established the foundation for every faster TBM that followed. In fact, Daher reports that the TBM family has now passed 1,300 aircraft delivered worldwide, with the program tracing its roots directly back to the TBM-700 that entered service in 1990. So while the TBM-700 may look old next to today's TBM-960 or TBM-980, it is not simply an outdated turboprop. It is the aircraft that started the formula, and for a buyer who finds a well-maintained example at the right price, that original formula can still be surprisingly effective today. Number 10. Daher TBM-850. At number 10, we reach the Daher TBM-850, one of the aircraft that really established the idea that a single-engine turboprop could deliver near-jet performance without the complexity of a twin-engine aircraft. Originally introduced as the Cessna TBM-850, the aircraft was the direct successor to the TBM-700 and brought a major increase in power with the Pratt & Whitney Canada PT6A66D, rated at 850 shaft horsepower. Depending on the cruise profile, the TBM-850 can reach speeds around 320 knots, or roughly 368 miles per hour, making it exceptionally quick for an aircraft of its age. The published maximum operating altitude is 31,000 feet, while maximum range varies with configuration and cruise setting, with long-range figures reaching roughly 1,500 nautical miles. That combination is what made the TBM-850 so impressive when it arrived. You had a pressurized cabin, seating for up to 6 people, retractable landing gear, high-altitude capability, and a turbine engine that could turn a relatively compact airframe into a remarkably fast cross-country machine. And unlike a jet, the TBM-850 could still retain the operating advantages of a single-engine turboprop, particularly when it came to fuel efficiency and access to smaller airports. The cabin is certainly not enormous, and that is one of the compromises buyers have to accept. This is an aircraft built around efficient transportation rather than a spacious executive interior, so passengers should not expect PC-12 levels of cabin volume. The aircraft is also older now, which means condition and maintenance history can matter far more than the model name itself. Buyers need to pay close attention to engine hours, hot section inspections, propeller condition, pressurization, landing gear, corrosion, and avionics upgrades. That age can also create an opportunity. A well-maintained TBM 850 can offer an enormous amount of performance for considerably less money than buying a new high-end turboprop, although actual used market prices vary widely depending on year, total time, engine status, equipment, and maintenance history. Another interesting part of the TBM 850 story is the evolution of its cockpit. Earlier aircraft used conventional avionics, while later examples received Garmin G1000 systems, making them much more attractive to pilots who want modern glass instrumentation without giving up the proven airframe. The TBM 850 is not perfect, and its smaller cabin, older systems, and higher maintenance demands compared with a newer aircraft are real considerations. But the fundamental design remains remarkably effective. Give a relatively lightweight pressurized airframe, an 850 shaft horsepower PT6 engine, and you get an aircraft capable of covering serious distances at speeds that still make passengers look out the window wondering where the propeller is. That is why the TBM 850 remains such an interesting aircraft today. It sits in a sweet spot between the original TBM 700 and the later 900 series models, delivering a level of speed and performance that still feels surprisingly modern more than 2 decades after its introduction. Number 9. Daher TBM 900. Moving into the top 9, we have the Daher TBM 900, and this is where the idea of a fast single-engine turboprop starts to become genuinely hard to believe. Introduced in 2014 as the successor to the TBM 850, the TBM 900 was not simply an older aircraft fitted with a more powerful engine. Daher redesigned and refined the airframe around the goal of making high-speed travel more efficient, easier to manage, and more practical for everyday owners and operators. It retained the Pratt & Whitney Canada PT6A66D, producing 850 shaft horsepower, but major aerodynamic improvements helped the aircraft reach a maximum cruise speed of 330 knots, or approximately 380 miles per hour. Daher also published a maximum range of 1,730 nautical miles and economy cruise fuel consumption of about 37 US gallons per hour, an impressive combination for an aircraft capable of jet-like speeds. The redesigned airframe featured cleaner aerodynamics and improved airflow management, while the single-lever power control simplified engine and propeller management and reduced pilot workload. This matters because the TBM 900 was designed to be more than a fast airplane on paper. It was intended to make high-speed personal and business travel practical for a single pilot. The pressurized 6-seat cabin gives passengers the ability to travel at high altitude in a more comfortable environment, while the aircraft's relatively compact design allows it to use smaller airports that may not be practical for many light jets. That flexibility is one of the TBM 900's biggest advantages. You get the speed of a light jet in cruise, but you still have the efficiency and airport access advantages of a turboprop. There are compromises, of course. The cabin is much tighter than a PC-12, the aircraft requires disciplined maintenance, and operating an older high-performance turboprop is not the same as owning a basic piston airplane. The PT6A66D is proven, but engine inspections, propeller condition, pressurization systems, landing gear, and avionics history all deserve serious attention when buying a used example. And this is where the TBM 900 can become particularly interesting in today's market. It is no longer a new production aircraft, but used examples are still actively traded. As of 2026, asking prices can approach $3 million for well-equipped, carefully maintained aircraft, with one current 2015 TBM 900 listing advertised at $2.99 million. Actual transaction prices can vary depending on total time, engine status, inspection history, avionics, interior, and overall condition. What makes the TBM 900 special is that its speed did not come from simply accepting higher fuel consumption and more complexity. Daher spent more than 3 years developing the aircraft, refining the aerodynamics and systems so that the 330-knot cruise speed could coexist with a 1,730 nautical mile maximum range and economy cruise consumption of around 37 gallons per hour. The result is an aircraft that still feels remarkably modern today. At around 380 miles per hour, the TBM 900 can cover serious distances quickly, yet it remains small enough to operate from airports that would be inconvenient or unavailable to many light jets. Number 8. Daher TBM 910. At number 8, we have the Daher TBM 910, an aircraft that shows just how far the high-speed single-engine turboprop concept had evolved by the time this model arrived. The TBM 910 was not designed to reinvent the TBM 900 with a completely new airframe. Instead, Daher focused on refining a platform that was already exceptionally fast, efficient, and proven, then improving the experience for the pilot and passengers. Under the cowling is the Pratt & Whitney Canada PT6A66D, producing 850 shaft horsepower, giving the TBM 910 a maximum cruise speed of around 330 knots, or roughly 380 miles per hour. That is the number that immediately gets your attention, because this is a 6-seat pressurized turboprop, traveling at speeds that many people would expect from a small business jet. But the real appeal of the TBM 910 is what happens around that headline number. The aircraft combines high-speed cruise with a range of about 1,730 nautical miles, allowing it to handle serious cross-country missions without turning every trip into a fuel stop. The pressurized cabin lets the aircraft operate comfortably at high altitude, where pilots can take advantage of smoother air and more favorable winds, while the relatively compact airframe allows access to airports that may be inconvenient or unavailable to larger business jets. The major upgrade over the TBM 900 is the Garmin G1000 NXI avionics suite, paired with a physical keypad controller that gives the pilot a fast and familiar way to enter flight plans, manage navigation, and interact with the aircraft's systems. That design choice is important because the TBM 910 was built around reducing workload rather than simply adding screens for the sake of technology. The cockpit gives the pilot a clear picture of traffic, terrain, weather, navigation, and aircraft information, while the advanced autopilot helps manage the aircraft during long, high-speed flights. Another advantage is the TBM's single-engine layout. There is less engine and systems complexity than you would find in a comparable twin, yet the aircraft still delivers impressive climb and cruise performance. Of course, there are compromises. The cabin is not as spacious as a Pilatus PC-12, the aircraft carries fewer passengers, and operating a 330-knot turboprop still requires a disciplined approach to fuel planning, maintenance, and high-altitude flying. The TBM 910 is also no longer Daher's newest model, with the TBM 960 offering newer technology, but that can actually make the 910 interesting on the used market. Current asking prices vary considerably with year, total time, avionics condition, maintenance history, and equipment. But well-kept examples can still command several $1 million, reflecting the fact that you are buying one of the fastest and most capable pressurized single-engine turboprops ever produced. What makes the TBM 910 stand out is not one revolutionary feature. It is the way everything works together. You get a proven PT6 engine, efficient aerodynamics, a pressurized cabin, modern Garmin avionics, long-distance capability, and near-jet cruise speed in a compact single-engine package. Number 7. Daher TBM 930. At number 7, we have the Daher TBM 930, and this is where the idea of a high-speed single-engine turboprop starts to become seriously impressive. Introduced as a more advanced member of the TBM family, the TBM 930 combines the proven 850 shaft horsepower Pratt & Whitney Canada PT6A66D with Garmin G3000 avionics, giving the aircraft a level of cockpit technology that feels much closer to a modern business jet than an older propeller airplane. The headline performance is still what grabs your attention, with a maximum cruise speed of around 330 knots, or roughly 380 miles per hour, and a range of about 1,730 nautical miles, depending on the mission and cruise profile. But the real reason the TBM 930 stands out is how effectively it turns that performance into a practical, everyday aircraft. The pressurized 6-seat cabin allows it to fly comfortably at high altitude, while the aircraft's relatively compact design means it can use airports that may not be convenient for larger business jets. That combination can save owners both time and operating complexity, especially on regional trips, where a jet may spend more time climbing and descending than actually benefiting from its higher speed capability. The Garmin G3000 cockpit is another major advantage, replacing the more traditional instrument panel experience with integrated flight displays, touchscreen controllers, advanced navigation, synthetic vision, traffic information, weather data, and systems monitoring. The result is a cockpit that gives the pilot a much clearer picture of what the aircraft is doing without overwhelming them with disconnected instruments. The TBM 930 also benefits from a single-engine layout, which keeps the aircraft mechanically simpler than a comparable light twin and contributes to lower operating costs, while the PT-6A66D has a long reputation for durability and maintainability. That does not mean the TBM 930 is cheap to own. It is still a high-performance turbine aircraft, and maintenance, insurance, training, hangar space, and engine reserves can add up quickly. The aircraft is also not the roomiest option in its class, and passengers expecting the cabin space of a Pilatus PC-12 will notice the difference. Another consideration is that the TBM 930 is no longer the newest TBM model, so buyers on today's pre-owned market have to weigh its excellent performance against newer aircraft with more recent avionics, safety systems, and cabin improvements. However, that age can also become an advantage for buyers looking for value, because a well-maintained used TBM 930 can provide remarkable speed and range without the price of a new flagship turboprop. New aircraft are no longer being sold as TBM 930s, so current pricing depends heavily on year, total flight time, maintenance status, avionics condition, and equipment. But the used market can make this aircraft far more accessible than its original new aircraft price suggests. And that is ultimately what makes the TBM 930 so compelling. It is not simply fast for a turboprop. It is a carefully balanced aircraft that combines jet-like cruise performance, impressive range, modern avionics, a comfortable pressurized cabin, and access to smaller airports in one relatively compact package. Number 6. Daher TBM 940. Just outside the top 5 is the Daher TBM 940, and this aircraft is a great example of how the high-speed turboprop evolved from simply being fast into being genuinely easy and sophisticated to operate. Built as the successor to the TBM 930, the 940 keeps the same proven 850 shaft horsepower Pratt & Whitney Canada PT-6A66D engine and a maximum cruise speed of 330 knots, or about 380 miles per hour. But the real story is what Daher added around that power plant. The TBM 940 was designed to reduce pilot workload without taking away the performance that made the TBM family famous. Its most important feature is the automated throttle, which was a first for a standard production turboprop in its weight category. Instead of constantly managing power manually, the system works with the autopilot and adjusts engine power to maintain the selected flight profile, helping the pilot get consistent performance while making high-speed cruise much less demanding. Daher also introduced automated icing protection, another major step for the category. The system can detect icing conditions and automatically activate protection for critical areas including the airframe, windshield, propeller, and engine particle separator, giving the pilot another layer of protection when conditions become difficult. Then there is the Garmin G3000 cockpit, which gives the TBM 940 a modern business aircraft feel rather than the traditional cockpit you might expect from a turboprop. The 6-seat pressurized cabin is relatively compact, but Daher focused heavily on comfort, adding redesigned seats, improved insulation, additional storage, USB charging, and a more refined interior. The aircraft also became notable for home safe, an emergency autoland system based on Garmin Autoland technology. If the pilot becomes incapacitated, the system can evaluate available airports using information about weather, terrain, traffic, fuel, and runway conditions before guiding the aircraft toward an appropriate landing. That technology is one of the clearest signs that the TBM 940 was designed around more than speed. It was about making a very fast aircraft more manageable for a single pilot. The downside is that this level of performance and technology does not come cheaply, and the TBM 940 is no longer Daher's current production model, so buyers today are looking primarily at the pre-owned market, rather than ordering a new one from the factory. Used examples can still command several $1 million depending on year, condition, equipment, and total flight time, so this is hardly a budget aircraft. But that is also what makes the TBM 940 so interesting. You are getting near-jet cruise performance, a pressurized cabin, sophisticated automation, and the ability to use airports that may be inconvenient or inaccessible for many light jets, all in a single engine package. The TBM 940 may not be the newest TBM anymore, but it remains one of the most impressive examples of how smart technology can make extreme performance much more practical for everyday flying. Number 5. Beechcraft Denali. Starting our original top 5 is the Beechcraft Denali, and this is one of the most interesting single-engine turboprops currently moving toward production. Unlike the earlier version of the script suggested, the Denali is not simply an old Cessna project under a different name. Textron Aviation now officially presents it as the Beechcraft Denali, and as of July 2026, the program has entered the final phase of flight testing, with certification activities scheduled to conclude in October 2026, and entry into service expected in 2027. That makes this aircraft especially interesting because it is no longer just a concept, but it is also not yet a customer-delivered production airplane. The Denali is built around GE Aerospace's Catalyst 1300 CS1A engine, rated at 1,300 shaft horsepower, and Textron is targeting a 285-knot cruise speed, or about 300 nautical miles, carrying 1 pilot and 4 passengers. What makes those numbers impressive is that the Denali is designed to deliver this performance without turning into a complicated twin-engine aircraft. The Catalyst uses dual-channel FADEC and digital engine management, while a single power lever controls both engine and propeller functions, giving the pilot a more jet-like experience and reducing workload. GE also designed the engine around advanced manufacturing techniques and technologies such as single-crystal turbine blades and additive manufacturing, with the goal of improving efficiency, performance, and long-term ownership economics. The aircraft uses a new Macaulay 5-blade composite propeller with reversible pitch, full feathering capability, and ice protection, giving the Denali a modern propulsion system from the engine all the way to the propeller. The cabin is another major reason this airplane stands out. Beechcraft says the flat-floor cabin is designed to be the largest in its segment, with a standard 6-seat executive arrangement or a 9-seat high-density configuration. There is also an optional belted lavatory that can be removed when additional cargo flexibility is needed. That gives the Denali a useful advantage over many high-performance turboprops, because it is being designed not only for private owners, but also for charter, corporate shuttle, and other multi-mission operations. Up front, the Garmin G3000 cockpit adds touchscreen controls, synthetic vision technology, integrated autothrottle, advanced flight management, and Garmin Emergency Autoland, which is planned as standard equipment when the aircraft enters service. The biggest drawback right now is availability. Because the Denali has not yet entered service, there is no established used market, and Textron has not published a confirmed retail price that can be treated as a current transaction price. So, unlike a PC-12 or TBM, you cannot simply shop for a production Denali today, but that may also be part of its appeal. If Textron delivers on the promised 285-knot cruise, 1,600 nautical mile range, large cabin, advanced automation, and lower operating cost targets, the Beechcraft Denali could become one of the most serious new competitors in the high-performance single-engine turboprop market. Number 4. Pilatus PC-12 PRO. At number 4 is the Pilatus PC-12 PRO. And this is one of those aircraft that makes you understand why speed is only one part of a great turboprop. The PC-12 PRO is not the fastest airplane on this list, and that is exactly what makes it so interesting. Its real strength is the combination of business-class comfort, impressive range, rugged airport capability, and relatively efficient operation in a single-engine package. Pilatus lists a maximum cruise speed of 290 knots, or about 334 miles per hour, with a maximum range of roughly 1,765 nautical miles. Power comes from the Pratt & Whitney Canada PT6E67XP, a modern engine featuring integrated digital engine and propeller control that reduces pilot workload and helps manage power more precisely throughout the flight. The PC-12 Pro also uses a single-lever power control, giving pilots a more streamlined experience than older turboprops. Up front, the cockpit is built around the latest Garmin avionics and advanced flight management technology, while the aircraft includes systems designed to improve situational awareness and reduce workload during demanding phases of flight. But the feature that really separates the PC-12 Pro from many light jets is its ability to operate from airports with relatively short or unimproved runways. The aircraft can work from paved surfaces as well as suitable grass, gravel, dirt, and snow runways, opening up destinations that a conventional business jet may simply not be able to reach. That flexibility changes the way you can use the airplane. You are not limited to major airports with long, perfectly maintained runways, so a trip that would normally require a long ground transfer can potentially become a direct flight almost to the final destination. Inside, the cabin is another major selling point. The PC-12 PRO offers a refined executive environment with comfortable seating, large windows, modern materials, and enough space to make longer flights genuinely enjoyable. The large cargo door is also a surprisingly important advantage because this aircraft can handle bulky luggage, equipment, and specialized cargo far more easily than many sleek business jets. The downside is obvious. At around 334 miles per hour, it cannot match the raw speed of aircraft such as the TBM 960 or Epic E1000 AX, and if your only goal is to get from one city to another as quickly as possible, there are faster options. The PC-12 also carries the purchase and operating costs of a serious turbine aircraft, so it is hardly a cheap airplane. However, that is where the value proposition becomes interesting. Instead of buying a faster jet and accepting the limitations that come with it, the PC-12 PRO gives you one aircraft capable of handling business travel, private transportation, cargo, remote airports, and demanding short-field operations. Current pricing is generally in the multi-million-dollar category, with the final cost depending heavily on configuration, options, and delivery specifications. What you are really paying for is not just a 290-knot turboprop. You are paying for an aircraft that can replace several different types of transportation with one remarkably versatile platform. Number 3. Piper M700 FURY. Now we reach number 3, and this is where Piper really turns up the performance. The Piper M700 FURY is not simply another step in the M-class lineup. It is Piper's fastest single-engine aircraft ever produced, combining the familiar efficiency of a turboprop with performance that starts to feel remarkably close to the light jet world. Powered by the proven Pratt & Whitney Canada PT6A52 engine, producing 700 shaft horsepower, the M700 FURY can reach a maximum cruise speed of 301 knots, or roughly 346 miles per hour, which is an impressive figure for a 6-seat, single-engine aircraft. Piper lists a maximum range of up to 1,852 nautical miles at normal cruise, while maximum speed operation reduces that figure to about 1,424 nautical miles, giving owners the choice between getting there as quickly as possible or stretching the aircraft's legs farther between fuel stops. What makes the Fury especially interesting, however, is that Piper did not chase speed by turning the airplane into an overly complicated machine. The aircraft remains relatively compact, efficient, and practical for owner pilots, while its pressurized cabin makes high-altitude travel much more comfortable. The real star is the technology inside the cockpit. Piper's Halo safety system brings together Garmin Emergency Auto Land, Auto Throttle, electronic stability protection, emergency descent mode, surface watch, safe taxi, and plane sync, creating a level of automation that would have sounded extraordinary in a single-engine turboprop only a few years ago. If the pilot becomes incapacitated, emergency autoland can take over the aircraft, select a suitable airport, communicate with air traffic control, and land automatically, giving the M700 FURY a safety feature normally associated with much more expensive aircraft. The auto throttle also reduces workload by automatically managing engine power, while electronic stability protection helps keep the aircraft within safer flight parameters. Another advantage is its ability to operate in known icing conditions, adding useful flexibility when flying across changing weather. And despite all this technology, the M700 FURY still retains the operating economics that make turboprops attractive in the first place. You are not feeding two jet engines, and you are not paying the same fuel and maintenance costs associated with many light jets. The trade-off is that the FURY is not inexpensive. New aircraft are positioned in the multi-million-dollar category, with pricing depending heavily on equipment and configuration. But buyers are paying for far more than raw speed. They are getting a pressurized personal aircraft, modern Garmin avionics, advanced automation, strong short-field performance, and the ability to cruise at speeds that make many passengers forget there is a propeller turning up front. Its biggest weakness is that maximum speed performance comes at the expense of range, and the six-seat cabin is still smaller than what you would find in larger turboprops, such as the PC-12. But that is exactly where the M700 FURY finds its identity. Number 2. Epic E1000 AX. At number 2, we have the Epic E1000 AX, and this is where the idea of a high-performance single-engine turboprop becomes genuinely hard to believe. Epic designed the E1000 around one simple philosophy: keep the aircraft light, make the structure extremely efficient, and give it enough turbine power to deliver performance that can challenge much more expensive aircraft. The result is a six-seat, pressurized turboprop built largely from carbon fiber composites, powered by a Pratt & Whitney Canada PT6A-67A, producing 1,200 shaft horsepower. Epic lists a maximum cruise speed of 333 knots, or roughly 383 miles per hour, with a range of about 1,560 nautical miles. Those numbers alone make the E1000 AX stand out, but the real story is how the aircraft achieves them. The carbon fiber structure keeps weight under control, while providing a sleek, aerodynamically clean shape, and that low-drag design allows the PT6A-67A to turn enormous power into impressive forward speed. Instead of being built like a conventional utility turboprop, the E1000 was conceived from the beginning as a fast personal and business aircraft, and that shows in almost every part of the design. The pressurized cabin gives passengers a quieter and more comfortable environment at high altitude, while the Garmin avionics suite brings modern glass cockpit technology into an aircraft that can cruise faster than many entry-level jets. Epic has also incorporated advanced automation, including Garmin autothrottle and an autoland system for the E1000 AX, as certification progresses, adding another layer of safety and reducing pilot workload. The aircraft's biggest advantage is clearly its performance-to-price equation. Epic has positioned the E1000 AX at a price level far below many new light jets, while still offering jet-like cruise speeds, a pressurized cabin, modern avionics, and long-range capability. That makes it particularly attractive to pilots who want speed without paying the acquisition and operating costs associated with a traditional jet. Of course, there are trade-offs. The E1000 AX does not offer the cabin volume or passenger capacity of larger aircraft, such as the PC-12, and as a relatively specialized high-performance platform, it does not have the same decades-long operating history or global support network as the established TBM family. It is also important to separate advertised performance from real-world operation, because payload, weather, altitude, fuel reserves, and cruise settings all affect how fast and how far the aircraft can actually fly. Even so, the basic concept is remarkable. You get 6 seats, a lightweight carbon fiber airframe, a 1,200 shaft horsepower PT6A-67A, modern Garmin technology, and a published maximum cruise of 333 knots. That combination makes the Epic E1000 AX one of the most interesting aircraft in the modern turboprop market. It is not simply a fast propeller airplane. It is an aircraft designed from the ground up to make people ask why they would need a light jet at all. And that is exactly what makes the E1000 AX such a fascinating number 2. Number 1. Daher TBM 960. Taking the top spot is the Daher TBM 960. And if the goal is to find a single-engine turboprop that feels genuinely close to a light jet, this is one of the strongest examples on the market. The TBM 960 combines a Pratt & Whitney Canada PT6E66XT engine with a Hartzell 5-blade Raptor composite propeller, and the result is a published maximum cruise speed of 330 knots, or about 380 miles per hour, with a maximum range of roughly 1,730 nautical miles. But the real reason this aircraft stands out is not simply how fast it goes. The TBM 960 was designed to make that performance easier and more efficient to use. Its dual-channel engine and propeller electronic control system gives the pilot a single digital power lever, automatically managing engine and propeller functions from startup through landing, while helping protect the engine and reduce pilot workload. At Daher's recommended 308-knot cruise, fuel consumption is about 57 gallons per hour, which gives the TBM an efficiency advantage over many jets with comparable travel speeds. The 5-blade Raptor propeller also helps reduce vibration and noise, making the cabin noticeably more refined than you might expect from a propeller-driven aircraft. Inside, the Prestige cabin adds upgraded seating, LED ambient lighting, electrically dimmable windows, modern environmental controls, and USB-A and USB-C charging. Up front, the Garmin G3000 flight deck brings together touchscreen avionics, weather radar, electronic stability protection, underspeed protection, emergency descent mode, and Daher's home-safe emergency autoland system. That last feature is particularly impressive because it can take over and land the airplane if the pilot becomes incapacitated. There is also a downside, and it is an important one. The TBM 960 is a relatively compact aircraft, so it cannot match the cabin volume or cargo flexibility of something like a PC-12, and operating a high-performance turboprop still requires significant pilot training and ownership costs. Price is another major consideration. The TBM 960 was introduced at roughly $4.8 million with the Prestige cabin, and well-equipped examples have been around the $5 million mark, with a nearly new 2023 aircraft recently advertised at about $5.2 million. Daher has since introduced the newer TBM 980, which keeps the TBM 960's PT6E66XT propulsion and adds Garmin G3000 Prime avionics, so the 960 is no longer the newest version, but it remains an exceptionally capable high-speed turboprop, and that is why it earns this position. The TBM 960 does not try to imitate a jet in just one area. It combines speed, range, efficiency, automation, comfort, and airport flexibility into one remarkably mature package, proving that a propeller aircraft can be seriously fast without giving up the practical advantages that make turboprops so appealing. And there you have 15 single-engine turboprops that completely change the way we think about propeller aircraft. At the bottom of the list, the Grand Caravan EX and Kodiak 900 show how much utility you can get from a single turbine engine, while aircraft like the M500, M600 SLS, and PC-12 PRO prove that speed and practicality can coexist. Then the TBM family takes things into another league, with the TBM 700 starting the high-speed formula and later models pushing all the way to 330 knots. At the top, the Epic E1000 AX and Daher TBM 960 show just how close modern turboprops can get to the performance of light jets, while retaining some of the advantages that make propeller aircraft so useful. So if you had to choose just one, would you take the rugged Kodiak, the versatile PC-12 Pro, the incredibly fast M700 FURY, the carbon fiber Epic E1000 AX, or the highly refined TBM 960? Let me know which one you would fly. And if you enjoy aviation videos that go beyond the usual aircraft lists, make sure to like the video, subscribe to the channel, and stay tuned for the next one.